A pleasant day, sir. A pleasant day, classmates. Massive increase in demand of construction pushes engineers to study properties of different industrial materials that is attainable and practical alternative in the field of construction. These alternatives must have at least similar characteristics and properties like cement. As we all know, foundation and the strength of the building is very relevant in making sure that the building won't collapse anytime and provide long period of time to amortize environmental land and economical cost. As a consequence, the researchers agreed to conduct experimental and testing method for fly ash as full replacement in Portland cement in concrete mix. Therefore, this research is concentrated on potential and characteristic of fly ash. The massive production of fly ash offers new opportunity to be used in conventional constructions and in any other areas of engineering. For the statement of the problem, this study aims to determine the potential of fly ash as a full replacement to Portland cement in concrete mix. Specifically, it seeks to answer the following. First, the physical and chemical characteristics of fly ash. Second, what are the properties of fresh concrete using fly ash as full replacement for Portland cement? Third, what are the properties of hardened concrete using fly ash as full replacement to Portland cement? And lastly, we are to determine the significance of difference in the compressive strength between fly ash and concrete mix and conventional Portland cement mix. For our assumption of the study, with a reference to the above research questions, the following assumption of the study were established, which became the focus of the research within the context of the study. On our first assumption, the physical properties of fly ash, such as gradation, specific gravity and absorption, fineness modulus and moisture content, and unit weight and voids can be determined. The chemical properties of fly ash can also be discovered. Second, the physical properties of concrete in terms of fly ash as full replacement in cement such as gradation, specific gravity, and absorption, fineness and modulus, and moisture content, and unit weight and voids can be identified. Third, the properties of fresh concrete using fly ash as full replacement of Portland cement in terms of workability can be determined. Lastly, the behavior of hardened cement with fly ash as full replacement to Portland cement in terms of compressive strength can be discovered. The researchers therefore considered that there is no significant difference in the compressive strength of common concrete and conventional concrete using fly ash as full replacement. Therefore, it is categorized as null hypothesis. For the scope and the limitation of this study delimits only on the investigation of adding fly ash to concrete mix and its effectiveness to fully replace Portland cement while reducing environmental risk and promoting fly ash utilization. Upon the completion of the research, review of related literature and review of related study has been done by the researchers. On the study carried out by Susante at 2021, they examined the effect of using fly ash in water-cement ratio on the strength characterization of the concrete. It is similar to the current study wherein the researchers want to know the effect of using fly ash in concrete. However, the only difference is that Susante uses only 30% of fly ash in the concrete, while the researchers of the current study want to use 100% of fly ash as a replacement in cement in the concrete. In this study conducted by Pradeep Nath in 2010, the durability on concrete with the use of fly ash as a partial replacement to cement was investigated. Pradeep Nath uses only 30% of fly ash in set A and 40% of fly ash in set B. The current study uses 4 sets, which is composed of 25% of fly ash, 50%, 75%, and 100% of fly ash in concrete to identify its durability. Mohed and D, on 2016, created a study entitled Sustainable Concrete by Using Fly Ash as a Cement Replacement. In this study, they tried to produce an alternative concrete that make a link between a long life structures and more environmentally friendly buildings. Mohedin D uses 5 sets of concrete. First is no fly ash, second is 15%, 25%, 35%, and lastly is 50%. The current study uses 25%, 50%, 75%, and lastly 100% of fly ash as a replacement in cement. So for the theoretical framework, the strength and functional is tested in different weathers, especially its strength in cold weather, especially at high levels of pollution is recommended replacement, but also can create delayed timeline in the finishing and starting stage of the construction. The workability of fly ash as an alternative is a very notorious topic. And most research for these identical characteristics that made it qualify to be a partial alternative to cement. Its workability is adequate to become an alternative. The rising price of cement became a burden and estimation of expenses to the client. This pushes the development to create a partial alternative which will make them lighten the price and pursue the building construction with no more inconvenience or second thought for the expenses they will be giving at the end of the service. Depending on the type of fly ash, concrete procedures claim that it is important in concrete mix design. The composition of industrial building is commonly added by 15 to 25% of fly ash in concrete and is ranged up to 40 to 60%. For our conceptual framework, this study focused on evaluating the effectiveness of fly ash in concrete mix. Consequently, the result of the experiment promotes an environmental-friendly concrete production as well as to help reduce the cost of construction process. This will make the construction industry to have an effective solution on the continuous increasing of material cost and lessening the carbon dioxide emission. The process undertaken in the study is presented in Figure 2. The first step involves the collection of materials to be used such as cement, lime as binder, aggregates in concrete, and fly ash. After collecting the materials, it will undergo the mixing process with respective design, mixes, and will be performed in compliance to the standard set by ASTM. After this procedure, the resulting mixture will be evaluated in its fresh state and analyze the properties of the fresh mixture. This will then allow to settle and cure at specified time frames. Along with its respective time frames, hardened mixtures will undergo compression test to determine the compressive strength. The results will be tabulated, analyzed, and interpreted. The last procedure is the presentation of findings and conclusions. We are now in Chapter 3, the research methodology. The scope of this chapter consists of methods used in this study. This chapter describes the research approach, the research design, the research methods and the research procedures, and the statistical statement. For the research method, in this study, the researchers decided to conduct an experiment and observation as potential research methods. Given the behavioral components included in this research, as a first step, the researchers also plan to carry out research on various topics related to fly ash. This approach reflects the desired outcome for the fly ash under investigation. In research procedures, the study's approach was divided into two parts. Number one is the pre-experimental phase, and the second one is the experimental phase. In the pre-experimental phase, this phase of the study consists of material investigation and material preparation. And for material investigation, this step covers the selection and identification of possible sources of materials for the study. First, we have the sand. Fine aggregates used is erosin sand. This material was chosen based on quality tests conducted by the DPWH Quality and Material Testing Department, which revealed that it is good quality of sand that impacts the cement mortar setting properties. Second, we have the cement. The cement used in this study was Portland cement, which has been confirmed and tested to meet ASTM C595 requirements. Next, we have the fly ash. In this study, Class F fly ash was used as it has greater ultimate strength attaining concrete because of pozzolanic reaction. Class F fly ash are generally more effective than other classes of fly ashes in reducing the heat of hydration. We also have the lime. The addition of lime to the mixture increases its strength by around 10%. Lime is only considered as a binding material. We have the experimental phase. This phase of the study starts when the materials for the study have been selected and identified. For the mixing design procedure, first let's go for the mortar mixture. Prepare the concrete mix with sand, cement, and water. Use Class A ratio, 1:2, for the mixture. On the platform, a measured amount of sand is spread, and then the cement is poured over the sand. In a dry state, the sand and cement is thoroughly mixed with the shovels numerous times until the mixture achieves an even color throughout and is streak-free. After the entire mixture is fully blended by twisting it from the center to side, back to center, and then to the sides numerous times. After that, a depression is formed in the mixed material center. 75% of the required amount of water is then poured into the depression and stirred with shovels. Finally, the remaining water is added, and the mixing procedure is repeated until the concrete has a uniform color and consistency. The overall duration of concrete mixing should not exceed in 3 minutes. For fly ash mixture, prepare the concrete mix with sand, fly ash, lime, and water. Use Class A ratio, which is 1:2, for the mixture. On the other platform, a measured amount of sand is spread, and then the fly ash and lime are poured over the sand. In a dry state, the mixture is thoroughly mixed with the shovels numerous times until the mixture achieves an even or color throughout and is streak-free. After that, a depression is formed in the mixed material center. 75% of the required amount of water is then poured into the depression and stirred with shovels. Finally, the remaining water is added, and the mixing procedure is repeated until the concrete has a uniform color and consistency. The overall duration of the concrete mixing should not be exceeding 3 minutes. For the molding of test specimen, which is 20 mm cube sample, within a total elapsed time of not more than 2 minutes and 30 seconds after the original mixing of the mixture, start molding the mortar and fly ash mixture separately. Fill each cube section with a 10 mm layer of the mixture. In 4 rounds, tap the mortar 32 times in each cube compartment in about 10 seconds. When all the cube compartments have been tamped for the first layer, fill the compartments with the remaining mixture and tap as instructed for the first layer. Tamping the second layer, use gloved fingers and the tamper to bring in the mixture that has been forced out onto the tops of the molds after each round of tamping and before commencing the next round of tamping. The tops of all cubes should extend slightly over the tops of the molds once the tamping is complete. Move the straight edge of the towel, held almost perpendicular to the mold, with a sewing motion over the length of the mold, to cut off the mortar to a level surface parallel with the top of the mold. In determination of compressive strength, ASTM C109, the step would have been conducted in a laboratory where it has a testing machine. The researchers would prepare the plain concrete and the conventional concrete with fly ash and bring it to the laboratory. That is all for the Chapter 1 and 3 of Group 5, entitled A Case Study on the Effectiveness of Fly Ash as Full Replacement of Portland Cement in Concrete Mix.